We are now going to take a look at a couple of problems which are going to be solved using the do while loop. Instead of directly going to the syntax, I am going to show you how you can print numbers from 2 to 25. That means all the even numbers starting from 2 till 25 using the do while loop. So what I am doing first is I require only one variable called as number with the initial value 2 because I have clearly said I want to start from 2 and stop up till 25. Now what is the condition? You should ask yourself that question first. The condition is as long as number is less than or equal to 25, I can keep going and printing this even numbers. So what I'm doing is I'm saying number is assigned the value 2. Then look at this. I am having this do while clause or do while construct. I am printing the number. Number is now 2. Now first it prints 2. Next time it should print 4. So I am increasing number by 2. Number becomes number by 2. So the new value of number happens to be 4. Okay. So here we'll make a value of number happens to be 4. Now number happens to be 4. So how long should I continue this process? As long as the value of number is less than or equal to 25. So I am doing this using a do while loop. So if you see here, this is a compound statement or a block. This is the do while syntax, the blue one, and this is the condition. The difference between while and do while is I am checking the condition after at least executing one time. So after checking the condition, there has to be a semicolon for the do while loop. Now number became 4. So I am going to print 4 as the output. From 4 it again increased, it became 6. 6 is less than or equal to 25. So I'm going to go back here and I'm going to print 6. Alright. Then what happens next? Number increases by 2. It ends up becoming 8. Now I'm going to do an out. I'm going to print 8. Number is increased by 2. It ends up becoming 10. 10 is still less than or equal to 25. I go back here. I'm going to next print the number 10. Then I'm increasing number by 2. It ends up becoming 12. Then 12 is still less than or equal to 25. I go back here. I'm printing the number. It prints 12. Number is increased by 2. It ends up becoming 14. 14 is still less than or equal to 25. I go back here. So I'm printing 14 now. Number becomes 14 plus 2. It ends up becoming 16. 16 is still less than or equal to 25. I go up here. So I'm going to print 16 as my next number. Then what do I do? Number by 2. Number now ends up becoming 18. 18 is still less than or equal to 25. I go back here. See out 18. Number now ends up becoming 20. 20 is still less than or equal to 25. I go back here. See out 20. So I'm going to print 20 here. Number now ends up becoming 22. 22 is still less than 25. So I go back. I end up printing 22. Then number is 22 plus 2. Number ends up becoming 24. 24 is less than 25. It's still true. So I'm going to print 24. Once I print 24, number now ends up becoming 26. So it's 26 is definitely not less than 25. So this condition fails. I come out of the loop and then I halt. So this is an example of how you go about doing printing even numbers from 2 to 25. It can be 2 to n or whatever number using a do while loop. Let's try to take a look at the syntax before we proceed to solve one more problem. So if you take a look at this, the do while loop is an example of a post test loop. Why is it called post test? Because here if you see, I am checking the condition after the loop executes at least once, whereas while and for are pre-test loop where the condition is being checked at the top. These are set of statements, cout and num. They are executed multiple times as long as this condition happens to be true. But the difference between a while and a do while is, in a do while loop, this block of statement, whether this condition is true or false, will be executed at least once. The reason for that is, First you are executing the statements and then checking the condition. So it is going to be executed at least once before the condition is tested. This is the syntax. Do statements. In our case, statements are cout and num is num plus 2. While is here, test condition is num less than or equal to 25 and the semicolon. Don't forget this semicolon. Now, flower brackets are better used when you're using a do while loop. Even if this is just one statement, put a flower bracket so that you don't get confused. All right. The test condition always must be followed by a semicolon. So this should give you an idea about the syntax of a do while loop. Now what we shall do is we shall go about trying to understand do while loop through one more program, because you're going to understand concepts only when we do a number of problems. It's never going to be by taking a look at theoretical concepts. So in this problem, what I'm trying to do here is, let me go ahead and try to first tell you what this problem is all about. Armstrong numbers are numbers in which the sum of the cubes of the individual digits of the number is equal to that original number. Nothing to be scared. Take the number 371. What is this? This is 3 cube plus 7 cube plus 1 cube. This is equal to 27 plus 349 plus 1, which is equal to 371. So if the sum of cubes of the individual digits of a number is equal to the original number, such a number is known as an Armstrong number. Although it's not very correctly done in your book, any number should be an Armstrong number, not necessarily a 3-digit. But they have only done it for a 3-digit number, so I'm only showing you an Armstrong number for 3-digit. It could be a 4-digit Armstrong number, 5-digit Armstrong number, and so on, but we are only checking for whether a given 3-digit number is an Armstrong number or not. 370 is 1 is 1, 153 is the next. Why? 1 cube plus 125 plus 27. How much is this? 7 plus 7 plus 5 is 12, 12 plus 1 is 13. So this is also 153. This is an example of your Armstrong number. So what we are going to do here is, in order to solve this particular problem, we will be needing to first split the digit using mod and division operator, and then take the cube and add it to a variable called as sum. So let's say call the num, let's start the number with 371. Then in one more column I need to hold the remainder, because I'm going to cube the remainder and add it to sum. And then this temp to maintain a copy of the original number, because this number is going to be lost during processing. You want to retain a copy in order to print the final result. I'm going to ask the user enter the number. User enters the number as 371. Now what I need to do is I need to see that sum is 0 first and the value of number is copied to temp. So temp also becomes equal to 371. That's what I am doing here. Why you should make sum 0? Because I am adding 0 plus 3 cube, which becomes 27. 27 plus 7 cube plus 1 cube. If you forget to make sum 0, you will never get a correct result, because this is going to be a garbage value. So that's why it's a very important step. Be sure you do not forget. So this program is going to work only for 3-digit numbers. If you want to make it work for n-digit Armstrong numbers, there's a little change. We're not going to bother about that. Now let's move ahead here. Let's take a look at this do while loop. What I am doing is I am working on temp. Okay, I'm keeping the original number as it is. I'm working on temp. 371 divided by 10. The remainder happens to be 1. So this is 1. Now what is sum? Sum is remainder cube plus sum. 0 plus 1 cube. So sum becomes 1. Now I need to lose this 1. So I'm going to divide temp by 10. 371 divided by 10, the quotient is 37. So temp now ends up becoming 37. Now what is the condition? As long as temp is greater than 0. This condition is still true. I go back here. Remainder is 37 divided by 10. The remainder is 7. Sum is 1 plus 7 cube. 1 plus 7 cube is 349. Okay. Now sum is 1 plus 349 is equal to 300 and how much is it? 7 cube is 349. 349. So it becomes 350. I just hope I have not missed something. Okay. We'll figure out when we are testing. All right. So sorry, it should be 343. 7 cube should be 7 sevens are 49. 49 into 7. Yeah, it should be 343, not 349. It is 343. Okay. So this is 344. Sorry, this should be 344. Sum is 344. Now temp is 37 divided by 10. The quotient is just 3. 3 is greater than 0 is true. Remainder is 3 divided by 10. Remainder happens to be 3. Sum is 344 plus 3 cube is 27. This is 7 plus 4 is 1. 4 plus 2 is 6. 6 plus 1 is 7. Now it is 371. Pardon me for this. 7 cube is 343, not 349. So now if you add all of this, now you're getting 371. Temp is 3 divided by 10. So quotient becomes 0. 0 greater than 0 is false. So I come down here. Sum. What is sum? Sum is 371. What is the original number? 371. So such a number is an example of a Armstrong number. It's going to print. Take some other number and draw a table like this and test out. You will find that the sum is not going to be equal to the original number. That number is not going to be an Armstrong number. So make it a point to run through this logic and understand it. It's really simple. You have to do a mod, multiplication and then division as long as temp is greater than 0. I'll again excuse me, 7 cube is 343, not 349. Somewhere I must have lost it.